Welcome back. Let me go quickly through the rest of the examples. This is a fork and we have tine, and as you can see, we have four tines. We are going to say that we are going to say forks have four tines. So one, two, three, and four. Okay, so that's what it is. Forks have four tines, and the way you could disprove me is to actually bring a fork that has three tines, that has two tines. But I'm saying that in a regular sense, if you go to any shop and you want to pick up the regular fork, you're going to see four tines. So what is my null hypothesis? My null hypothesis is forks have four tines. How do I take a look at this? How do I understand that? I'm going to get samples from 10 shops in Eastern Coast, and I'm going to get samples from 10 shops in the Western Coast, and then I'm going to open up the boxes. I'm going to take a look at the forks, and I'm going to take a look at the tines. In this case, I believe that you will see that from the samples you took, all of the forks have four tines on samples taken on the east side and samples taken on the west side. So what does that mean? There is no significant difference. Maybe there is one box, you pick it up and the fork is faulty and one of the tine is missing. So there is no significant difference between the two samples. So you're going to say, this is my null hypothesis. What is your alternative hypothesis? Forks have um, uh, have um, uh, uh, have less or more than four tines. So this way you are opposing the null hypothesis. I didn't say three, I didn't say two, I didn't say five, I didn't say six. I simply said less and more than four. Again, we get there and you will see what I mean by alternative hypothesis. I forgot to bring this cat to your attention the last time in one of my recording, but that's okay. That was about left and right paws of cats, okay? Um, does the race matter in education? You could potentially replace that in a positive sentence and say, race matters in education. How do you do that? You're going to collect, you are going to take a look at the entry level students and the exit level students, and you're going to take a look at the race as they have described, and you're going to correlate that with the a number of people who are exiting the education platform, and you're going to basically come back and say, yes, it seems to be that when I take two samples, I can clearly see that race has an impact on education. I take two samples from University ABC, University DEF, and I can clearly see that race has an impact on education. I can see that it does exist in those two samples. I would say these two samples are not different significantly. Okay. Now, what is going to be opposite to the null hypothesis is that race does not have impact on education. Of course, this is open to debate, and there are race in many ways. You could potentially even bring different variables that you haven't considered. As a domain expert, for example, you might bring race, not only race, but also the parents' income. And this is very clear that the parents' income has an impact. You could potentially bring in basically, I would say, the weight. You could say the weight, accessibility to the educational system, okay? So you could potentially look into international students while there are people from a different country, without naming names, may struggle in terms of education. There are people from specific countries that actually have pushed their children to the limit, and they have been trained in a framework, frame of mind that actually aim for success in education. These are the examples where you could see that I'm going to have samples of Indians, Chinese, white, whatever you call. And these samples, I'm going to take a look and see whether they are going to be an important relationship that I have between the origin of the country versus the success that they have in the education. This is simple. We are going to say all humans, perhaps with small differences between male and female, have approximately 36 degrees centigrade body temperature. Okay, so what does it mean? Humans have 36.5 degrees body temperature. That's what I'm going to say as my statement. Is this a null statement? The way I'm going to say it, first and foremost, this is a common sense. It has been there for, I would say, 1,000 years, where people have been able to actually measure the temperature using the devices that they have. So the accumulated evidence is actually supporting this. I don't go around and measure the temperature of the people. It's really nonsense to go onto the street and ask people to basically give you their body temperature. There has to be a reason, right? This is actually quite odd if you want to do it. Now, but generally speaking, if you wanted to do this scientifically, perhaps using clinics as your source of information, you could potentially have a sample A and a sample B, and you have 2,000 people in sample A and 2,000 people in sample B, and you get the temperature and you see 1,980 people have this kind of temperature and 20 have a bit of a fever, or maybe their temperature is below 36.5. Both ways can happen. And you take a look at these two samples and you don't see much of a difference between these two. We call this insignificant difference between these two samples. And then your alternative hypothesis is body temperature is not 36.5, which means it is above 36.5 or below 36.5. And by the way, when we say 36.5, we consider 37 as a natural body temperature. We consider 36 as a natural body temperature. And at the same time, this 0.5 on top and 0.5 at the bottom, there is an intersection between this healthy individual, 36.5, 37, 36, so 36 to 37, that's my window. And I'm going to consider that as my healthy individual with the appropriate body temperature. My hypothesis, what does it say? It says not 36.5. You can see that this 0.5 on top and 0.5 at the bottom is included in my in my alternative hypothesis. I'm going to show you the graph in a moment where this intersection is insignificant unless when some of the values we calculate are significant, such as p-value, and then you are going to begin to suspect that the null hypothesis is incorrect. You reject the null hypothesis, okay? Once the last thing that I wanted to do, and closing this portion of the class, and I hope through many examples that I provided to you, you are now ready and in a structured way to give me null hypotheses, alternative hypotheses, create the samples and discuss the samples and tell me what to look for, the variables of interest and so on. Here it is. We have election. It's a very hot topic, as you know. And then the only way you would know who won the election would be through the legal process, election process that is approved and monitored by federal and state level agencies and gone through the certification process and everything else. That's the only way the Constitution allows you to declare a winner. With that in mind, we don't want to ask 190, 200 million people to tell us now, before the election night, who they vote for. That's not possible. And the way we are going to do it, we are going to actually resort to sampling. So I'm going to take samples, and if I have sampling, I don't have sampling here. So I'm going to actually take samples, perhaps 3,000 people by phone, and 3,000 people by phone at some point. And then, for example, here, And this is a time wise. So 3,000 people here. I'm going to see how many people are voting blue and how many are voting red. And then here I'm going to have another 3,000 people. And inside I'm going to make a decision what the sample itself is actually telling me. So these are very important examples where you are required to carefully think about sample and sampling. We might as well have some topics covered in terms of sampling, but I wanted you to realize that as a scientist, the onus is on you to write the hypotheses, to identify if this hypothesis is a null hypothesis or an alternative hypothesis, to establish the samples that I need to investigate, to discuss the variable in a simple way, and to also consider many variables that you did not consider in the first place, excluded them in the first place, and be conscious whether those extra variables have important impact or not. This is really an important lesson that I hope you take away from these segments. I'm going to continue. My discussion is going to continue into normal distributions in a moment, and then we are going to continue into basically the next few links. This is a very important topic, and then we are going to have a lab design around this. Thank you.